Dr. Jayanarayan Tudu is currently working as an assistant professor in the Department of Computer Science and Engineering. His
Can you
research
get it?
span the area of computer hardware and AI accelerator design. He has published around 40 research articles in this area. Currently, he also is heading in India Semiconductor Mission of Government of India. He has been on a mission to understand the non-computational nature of consciousness. In this regard, he has been working in collaboration with Bhaktivedanta Institute and NIAS Bangalore. He graduated with MS and PhD from IISc Bangalore in Computer Science and Engineering. Over to you, sir.
So what I'll be talking about is what has been covered largely by the Sushant and Prabhakarji. So it may intersect some of the topic as time progress. Maybe I can skip so that we can quickly kind of get to the topic. But my point of the focus is the Turing test. How are the Turing tests are being revised in the new form in the context of the ML, right? Not the earlier. So let me connect the dots that has been put together. I mean, the presented by the Sushant. So Sushant has talked about the the challenges that the computational devices are throwing. If you carefully look at whatever the computational device that we have, which we call it as computers, they are basically a mathematics in extended form. If you look at the underlying, it's a mathematics, but the mathematics which you can see very quickly. If you do the mathematics by the human being, it may take say few years of the time. But if you the same math you do it in the computer science, you can do it quickly, which means that the visibility of the outcome is so quick that it is becoming perplexed to the human mind. So that's the thing. So the Sushant has argued on a fundamental or let's say foundational way, which John Searle's argument he has presented. What we call it is a the room Chinese room theory, right? It's basically it seems that the point by which that establishes that understanding is the one which is lagging behind by the machines. It's basically the understanding is the one point that through that argument, basically John Searle is a philosopher. If you've heard his talk, he is an exemplary, philosopher basically. So that's the one. And what Prabhakarji has talked about is the ML. Largely, I'll also be covering some of them, but let us look at what, if you carefully observe ourselves, the society as such, why we have come to this point of the machines and talking about the MLs and other things, right? So the one of the reason carefully is that we, the human being, possibly have realized that we are limited by ourselves. Therefore, we need some kind of augmentations of the other devices. So for example, if you carefully look at mechanically, we are very much limited in the sense that I can run, let's say at max 40 kilometers per hour, but not more than that, right? So if I have to really do more than that, so I need an augmentation of, so therefore you created a mechanical instrument, right? That you have the automobile kind of things. So similarly, so this is at the physical level, we wanted to extend our limitations. If I have to lift say, 100 kilogram of the weight, I may not be able to do it, but it will bring up the crane, so it can able to do it for me. So that's the extension. So in fact, Dr. T.D. Singh has also called this an extended senses which we extended. So similarly, if you have to see the things which are far or very small or the very large, we need a devices which augments our limitations of our senses. So similarly, we have come to the point where we have possibly extended most of our physical or let's say some extent the senses also, but not really the subtle senses in terms which enables us to think kind of thing. So therefore, through this computational device, possibly we are trying to extend that limitations of how far we could be able to think. So that is where the computational devices with the ML is possibly helping us or making us fascinated. So this is what is that. So therefore, if you carefully look at how the computational devices have evolved, it is basically starting from the counting, right? Count. You just count the discrete numbers. Let's say 1, 2, 3, 4, 5, 6. That's the one level of computation. So you don't call it as computation. So you can call them as a counting. You are just counting them. But we have extended that and we have taken it to the level of the computing it. So which means that you have tried to add the two numbers. you have tried to multiply the two numbers, 2 plus 2, you call it as a 4. So not just that, you could able to solve some of the rigorous mathematical equations, right? Solving system of linear equations may not be so much easy and the faster just if the human being does, but if you do the same thing in the computational device, very quick. That's right. So that's what we call it is a, computing. You do the computations. And that computation has been now added by the learnable capabilities. So which, if you look at the definitions of the AI, which people call the learning from the experience, which means that whatever you have done earlier time frame, so you are accumulating that, and the second phase of the computations which you are doing, that has been augmented by that. So which means that you are improving your performance, or let's say your accuracies kind of thing. So that's what we call it the AI-based computations, and there are respective devices for that. You have counting device, it can just count, it cannot compute. You have a calculating device, it can calculate, but it cannot compute. You can't use the calculator to solve the system of linear equations. But you can use your supercomputer or the laptop for that matter to solve a system of linear equations. We call it as a computations, right? But more than that, what we are going to discuss, and I think Prabhakarji has covered it. So this is how things has evolved. Possibly we wanted to reach little beyond than that. And also people are talking about the awareness of the conscious-based computations. But of course, the point where we differ is the definitions. What is the definition, or what is the working definition that you're talking about the consciousness when you talk about the computation devices are aware? So that is where possibly the crowd that we are gathered here, right, differs kind of things. And that is where possibly we are looking for the synthesis of these two domains. So let us start that how we the human being learn. Let me ask you a few questions here. Possibly you can answer, otherwise you'll go ahead. So what is the first object that I'm showing? Ripened mango, right? So this is the point I wanted to make. This is how we learn. Is there anyone who has never seen mango before? Not really, right? But if you bring up a small kid who has never seen the mango before, how do you expect him to answer the first question? Exactly. That is what we are going to call about is a learning. And as a computer science, we wanted to model that. The way we learn, right? Not the first answer when I asked you, you guys said it's a fruit. Some said fruits. Not really mango. Second answer was mango. Third answer was ripened mango. Fourth answer was yellow mango. Little more and more and more and precise, right? So this is the problem of the generalization also we call it. Fruit, this is not really fruit. It's a fruit, but not exact. That is not the exact answer, right? There are many other fruits, but yellow mango is the kind of answer. But yellow mango, eatable yellow mango is really more precise answers. So this is how also the machine learns. And this is how the genius of the machine learning people comes. Second one is possibly fruits. Let us do the third, the last one. Could you if you are able to see it? What is this image? Ramanujan is there. That is very precise answer, right? Standing among the other mathematicians. So this is how we learn the machine. And that is what we also wanted to model it. All right. And here we really don't differ in terms of the machine, right? Whatever the answer that you have given, machine can also exactly give the same answer. All right. So where we differ is the point where then how does the machine learn? I think Prabhakarji has already kind of covered it. So here is a training set in terms of the dots. So training set you have all means that you have already seen mango before, right? If you would not have seen the mango before, possibly you would need a training. Someone would say, or your father and mother would have said, told to you, this is called the fruits, then this is a mango. Then you would have answered, all right, this is a mango. But you have not seen, you could not answer the last questions, right? Because you might not have seen the image before. So this is a training set, and you draw a curve here. We call it as a curve fitting, and that becomes the inference, or what we call a testing page. And how do you do the inference is by minimizing the loss functions. And basically minimizing the loss functions is trying to reach to this point, which you call a local minimum, starting from somewhere here. So there is a mathematics involved, which we call it is a grade. So you try to figure out the rate of change of these functions, how it is changing. So the moment it becomes a 0, you call it as a minimum, right? Yes, you call it as a gradient. It's a gradient descent algorithm. We call it the gradient descent, gradient descent, or the derivative also you can call it, but it's a multi-dimensional. So so this is how it learns. So I'll quickly pass over because these have already been covered. And let's go to the Turing test. So the point I wanted to make is these are all algorithmic in nature. All right, they are all algorithmic in nature, and they are running in a computers which are hardware. Yesterday also, if you would have heard about the last talk Federico has given, right? He is a computer scientist, but now turned into a consciousness kind of scientist. He was also mentioning that whether a single transistors can have some sort of consciousness or not. It is not the concept. But here, so it's algorithmic in nature. That's the first point that you have to kind of take away from this part of the presentation is it. So here is the definitions, working definitions. Mitchell, it's like a CMU professor. So what he says is a computer programming is said to learn from experience. So yesterday also we are trying to distinguish that human can experience, computer cannot. But here they are saying it's experience, right? So which means that we need to study a little more that what we, the computer scientists, mean by the experience, what you, the the spiritualist mean by the experience. All right. Experience E with respect to some class of task T performs measures P. If it performs at a task T, the measure improves. So basically improves with experience. So that is what you mean to say. Improves with the experience, and machine is doing it. All right. So here are some of the, these are the algorithmic steps. We can skip here. So, therefore, this has become a really fascinated, and the recent fascination is what the Prabhakarji has talked about, the large language network or the model, LLM, right? So which means that it has been trained in a very vast network of the data, which are available out there in the internet, or they have created the data set, and it is able to answer the fantastic questions answers. You will not be able to really distinguish. Ordinary Turing test fails. We need really sophisticated Turing test. And what we are trying to think about is something which is really inspired by our Vedic wisdom. So that is what is our real target is. Let us see whether we are able to reach it. So therefore, these are some of the interesting questions already covered. So the thing is that we are looking for this point. Here is a point. AI might be much more superior for some of the definition of the intelligence, but we have to figure it out. So other definitions is the definition inspired by the Vedic wisdom, and looking for this point from where these two things diverge. So this is what, and most of the Turing tests, you could say the GPT-4 and GPT-3, they have performed much better than the human being, right? 95%, which means that they are much better than the 95% of the people who appeared for the GRE test. So these are tested on the GRE test. These are tested on the GRE and some of the medical examinations, and machine really performed well. But there are other tests people have devised where machine really failed, and that is what next point is. All right, let us do it. This one, another exercise. Here is a training, and this is the output of this. So you guys have to learn it, all right? And I have the questions, you have to answer it. So this is a task A. So here is a figure in a grid, all right? So you just have to say in this figure, what are the similarities, all right? So that's the training. Understood? Got the point? All right. So could you please say, so here, these are the examples. So in this figure, these two are similar, but this does not look similar, right? So you can delete these two. So this will be the answer. So the second examples, these two look similar, but again, also these two look similar. This is not really similar, but these two are similar. So therefore, others you can delete and you can answer this. All right. So you are learning. You are learning. So here is again training. So in this figure, so this is the output. All right. So you have deleted this because this is a dissimilar one. Now the testing. Yeah, what will be the output here? Two zeros, right? Everybody agrees on this? Disagreement is also acceptable. Okay. So this is okay. Yeah. What about the second one? Yeah, here is some cut, but this is exactly. So these two should be remaining, right? Yeah. So this is the test. This is a training. This has been given to both human being as well as the machine. All right. So training set is very small, only 2-3 figures, and you human being could able to learn it. You are able to answer it. simple logical questions. But machine could not do it. Okay, so that's the things. Machine could not do it. So that's this is the same another question. So the second test, this here also it failed. So that's same again. So these two you can delete this, and these two are kind of same. Verticals figures. Okay. Second one horizontally equal these two same. Here, yeah, output diagonal this, is it? So how are you doing it? How are you? I mean, you means we both, all of us. Pattern, okay, yeah, you are comparing pattern. So this is a simple, is it very simple? But then why the machine is not able to do it? What about this? Straightforward, is it? There is nothing to delete here. They are similar. You see, like, so here is the result, and ML model could only do few, maybe all wrong. Yeah. So now question is how the machine is filling here, but the human beings are really able to solve it very quickly. That could be the one of the answer. Possibly it training set is very less. So our training, but we are, although the training set for us is very less, but we are able to got train and able to answer it. And all the answer that you gave is correct. ML, yes. Yeah, they are also trained. Yeah, that's what I'm saying. They are also trained, but possibly the training set here only, but they are trained only in this. They are not given any other training set. Yeah. So the equal training set for both the human being as well as the ML. Yes. So there are two ways. So you have to train the model first, or you have to use a pre-trained model. And later on you can modify it or tune it, actually fine tuning of the parameters. But in this case, they are trained. Yeah, they are trained on this training set, the way we got trained, right? We started from here. So these are our training set. It's an ML. No. It's an empty model, which has been designed for this, and trained. In the model, this is not my work, of course. So this has been reported in the Nature that I have reported here. Yeah. Here, yeah, Nature it is. So this is what is one of the tests that has failed. So this is where you also wanted to build similar kind of test. So therefore, on what basis we should be looking at? So therefore, the nature of the Turing test that we are looking for is something which is based on our basic wisdom. So that's what is our next step is. So how do we do? What are the ways? Therefore, we could able to look at that, all right, maybe the AI models are algorithmic in nature. So we have to see what are the non-algorithmic or intuitions. How can we embed the intuitions into the Turing test? That's the first point. Done? Yeah, kind of done. I'm also done. So similarly, so I would like to talk about the creative and the free will. And let's see. So here is another example. We call it a Strassen matrix multiplication. The way it has been done is really something which talks about the creativity of the human being. Yeah, you can look at the story and the history behind it. And this is an algorithm which human being has solved, but coming up similar kind of algorithm in the machine seems to be a little tough. This is a model, possibly the last talk will cover it, so I'm skipping it. I'll just talk about whatever that we are trying to do. So we are trying to do something called the signature analysis to see, to find out, or let's say to devise a Turing test which is based on the uniqueness of the human nature. So which means that we wanted to see that, let us ask a simple signatures. We'll collect the signatures of the same person in the different point of time and repeatedly asked to sign his name or something like this, and then analyze it and what is the patterns of the uniqueness that is coming out. And similar task will do it for the machine model, asked to generate the synthetically the signatures and analyze it and see where does it falls. So this kind of things, that is what we are doing. So I have given you briefly the where does the Turing test stand as of now. All right. So, and from where we can take it further as a synthesizer of the science and spirituality. So here is a conclusion. So therefore, and I would like to invite you to come to Tirupati. It's a spiritually enlivening place, and also IIT is there. It's a beautiful campus. You can release the life. Thank you very much.